Cave Johnson here, CEO of Aperture Science, and today, for reasons that are frankly beneath me, I'm going to teach you HSC food technology. Now, I didn't get where I am today by eating unsafe food. I got here by understanding how food is made, preserved, packaged, and regulated by a frankly excessive number of government bodies. You're going to learn all of that right now. Science isn't about why. It's about why not. Why not memorize every food additive code? Can't think of a reason. Let's begin. Raw materials. Raw materials. Everything used to manufacture food. 4 types. Write them down. Ingredients: milk, flour, sugar, meat, vegetables, the stuff that actually tastes like something, food additives. Colors, flavors, preservatives, antioxidants. We'll get to those. They're fascinating and also slightly controversial. Aperture loves controversy. Processing materials, water and steam. Yes, water is a raw material. Don't argue with me. Packaging materials, glass, plastic, metal, cardboard. Also raw materials. The box is part of the product. I don't make the rules. Well, actually at Aperture I do. But in food technology, FSANS does now. Quality control of raw materials. Every incoming material must be free of impurities and contaminants and meet the manufacturer's specifications. A documented check sheet. Because if your raw materials are garbage, your product is garbage, and your company loses money. 4 QC steps. Describe the material, take a sample, test it, then take action. Accept, reject, or control. Failed materials go back to the supplier. No payment. Consequences. Specifications cover sensory characteristics like color and aroma. Physical characteristics like size. It has to fit the machinery. People. Chemical characteristics like pH and moisture, and biological characteristics like microbial limits. A team from R&D, quality assurance and production sets these specs. If you can't test a characteristic, don't specify it. That's just logic. Food additives, any substance added to food for a technological purpose that you wouldn't normally eat by itself. Identified on labels by class name plus a code number. Thickener 144. Simple. 4 uses. Improve safety and shelf life. Improve how the food looks and tastes. Improve nutritional value and aid manufacturing. Emulsifiers stop things separating. Raising agents make things rise. Anti-caking agents stop powder from clumping. All very sensible. Here are the ones you need to know. Antioxidants prevent rancidity in fats and oils. BHA code 320. Emulsifiers stop oil and water separating. Lecithin code 322. Humectants prevent moisture loss. Glycerin. Preservatives stop microbial spoilage. Sulfur dioxide 2020 in dried apricots. Nitrates 250 in processed meat. Flavor enhancers make things taste more like themselves. MSG 621, colors tartrazine 102, thickeners 1412, sweeteners aspartame 951, FSAN E, fecunds taste more like themselves. MSG 621, colors tartrazine 102, thickeners 104012, 112 in 14012, sweeteners aspartame 951, FSNZ. Food Standards Australia New Zealand approves every single additive. 3 criteria must be met. Safe at the requested level. Good technological reason. Consumer clearly informed. The ADI, acceptable daily intake, is the amount you can eat every day for your entire life without dropping dead. About 400 additives are approved. About 50 cause adverse reactions in some people. Digestive problems, hyperactivity, asthma, skin rashes. The main culprits: MSG, tartrazine, sulfites, aspartame. If you're sensitive to those, read your labels. That's what labels are for. Equipment, production, equipment. SHED, that's the acronym. Strong, withstands large volumes, keeps workers safe. Hygienic, stainless steel, non-reactive, non-corrosive, easy to clean, SIP cleaning in place, cleans equipment without dismantling it, using chemicals, heat, and water. Efficient, no delays, consistent product, energy efficient, reliable. Durable, runs 24/7 without falling apart. If your equipment falls apart, that's an engineering failure and frankly an embarrassment. 5 production systems. Small scale, domestic equipment, piping bags, KitchenAid. Manual, humans doing it by hand. Slow, expensive, inconsistent. Fine for hand-dipping chocolate truffles, not ideal for feeding a nation. Large-scale production lines, economies of scale, Arnott's biscuits. Automated machines with preset specifications handle everything. Computerized, sensors run the whole thing 24/7 and log every batch number, pH level, and timestamp. That's the Aperture way. 9-unit operations, everything raw materials go through to become a product. Separation, sieving, filtration, centrifugation, spinning things apart by density, like separating cream from milk. Size reduction, slicing, dicing, grinding, milling, mixing, heating, canning, baking, heat exchangers for pasteurization, cooling, blast chillers, plate chillers, freezing, evaporation, concentrating liquids. Evaporated milk is reduced by 60%. Dehydration, removing moisture to 5 to 25%, and handling of raw materials, conveyor belts, forklifts, laser-guided robots. Yes, robots freezing, key fact. Quick freezing makes small ice crystals, minimal cell damage, good quality. Slow freezing, 0 to -5 degrees, makes large crystals that rupture cell walls and destroy texture. Don't freeze things slowly. That's not science, that's just making things worse. Best drying method, freeze drying. Sublimation, ice becomes vapor, skips liquid entirely, under vacuum. No heat damage. Best nutrients, best flavor, best structure. Everything else is a compromise. Flow process charts, vertical step-by-step production visuals. Circle, operation, square, inspection. Arrow, transport, D-shape, delay, which is costly and should be eliminated. Triangle, storage. Circle inside square, both happening simultaneously. Use these to identify critical control points and train new staff. New staff need a lot of training. Quality management system. Policies and procedures for a safe, reliable food supply. QC happens during processing. QA manages the whole system. You need both. HACCP, hazard analysis critical control points. 7 steps. 1. Assess hazards. Raw eggs, cooking temps, cleaning chemicals. 2. Identify critical control points, places things can go wrong. 3. Set critical limits, the acceptable range at each CCP. 4. Monitor, regularly observe and record. 5. Corrective actions, discard the food and retrain the staff. Both. 6. Verify the system works, review it regularly. 7. Keep records, for audits and improvements. No records means it didn't happen. GMP, good manufacturing practice. Consistent production to quality standards. Documented proof every single time, not most times, every time. ISO 22000, International Food Safety Management, applies to everyone in the food chain regardless of size. After the 2008 melamine milk crisis in China, ISO developed a standardized test for melamine in milk. That's what accountability looks like. WHS Act 2011, employers provide safe equipment, proper training, PPE, and monitor worker health. Businesses over 20 staff form a WHS committee. Employees use PPE, report hazards, use equipment correctly. If you don't follow WHS, people get hurt, and then there are lawyers. Nobody wants lawyers' legislation. Federal government sets the standards. State enforces them on the factory floor. Local councils inspect your premises. That's the hierarchy. Memorize ITF SANS, established by the Food Standards Australia-New Zealand Act, 1991. Develops the Food Standards Code, 3 chapters. General standards including labeling and additives, food class-specific standards, and food safety standards. FANZ also coordinates recalls. 608 recalls between 2007 and 2016. Average 61 a year. Common reasons: foreign bodies like glass or plastic, undeclared allergens, microbial contamination, chemical contamination, processing failures. FANZ prevents misleading claims. They do not mess around. Advisory bodies. AFGC represents the food and grocery manufacturing industry. Nutrition Australia promotes public health. Australian Beverages Council covers non-alcoholic drinks. Also Diabetes Australia and the Heart Foundation. Federal Acts Competition and Consumer Act 2010. Food must be safe, fit for purpose, and acceptable quality before leaving the facility. Creates legal liability for manufacturers. Don't sell bad food. You will be sued. Biosecurity Act 2015. 60,000 kilometers of Australian coastline. X-ray machines, surveillance, and detector dogs. 2017. Prawn imports from Vietnam, China, and Thailand suspended due to white spot disease. The border is not a suggestion. Gene Technology Act 2000. GMOs need licensing and risk assessment and must be declared on labels. Codex Alimentarius. International standards from the FAO and WHO, covering 99% of the world's population state. NSW Food Act 2003. Ensure food is safe. No misleading conduct. Enforce the code. NSW Food Authority conducts unannounced audits. Risk profiling. Priority 1 is high risk and inspected constantly. They publish the names of non-compliant businesses publicly. That's a powerful deterrent. EHOs, environmental health officers, inspect without notice. Take food samples, issue fines, close businesses. No appointment necessary. WHS Act protects workers. Environment Operations Act 1997 prevents pollution. NSW Fair Trading Act 1987 stops misleading labeling. Free trade agreements, managed by Austrade, open overseas markets, but also bring more imports in. That's how trade works. Preservation, 5 reasons to preserve food. Safety, nutrition, acceptable form, year-round availability, economic viability. Food preservation is, frankly, one of humanity's greatest achievements. Right up there with the portal gun. 5 causes of spoilage: chemical rancidity and pesticide contamination, physical bruising and freezer burn, infestation rodents, insects, pantry moths, microbial bacteria, mold, yeast, enzymatic browning, over-ripening, decomposition. Spoilage you can see, smell and taste. Food poisoning, you cannot. This distinction has killed people.
Remember it. Microbes need warm temperatures, 20 to 40 degrees Celsius optimal, moisture, nutrients, time, low pH for some, and usually oxygen. 4 growth phases. Lag, they're adjusting. Extend this phase as long as possible. Log doubling every 20 minutes. 1 bacterium becomes 1 million in 3 hours. That is not a joke. Stationary growth equals death. Death, rapid die-off. Aerobic bacteria need oxygen. Anaerobic don't. Clostridium botulinum grows in improperly canned food. Facultative go either way. Salmonella, Staph aureus. 4 preservation principles. RACAR, removal of moisture. No liquid water, no microbial activity. Microbes go dormant in ice, but enzymes are still slowly active, which is why you can't freeze food forever. A. Addition of chemicals. Salt and sugar bind to water and reduce water activity. Acids like vinegar denature enzymes and lower pH. Higher acidity means less heat required to kill bacteria. Efficient C. Control of temperature. Damage above 60 degrees. Mostly dead at 100 degrees. Clostridium botulinum laughs at 100 degrees and survives for 5 hours. Needs pressure cooking. Danger zone 5 to 60 degrees Celsius. Don't leave food there. E. Exclusion of air. Remove oxygen. Most microbes go dormant. Hot fill uses steam. Vacuum packing removes all air. MAP replaces air with a controlled gas mix. Anaerobes still survive vacuum. Refrigeration still required. pH, pathogenic bacteria thrive above pH 4.6. Below 4.5 is high acid and much safer. The processes: HTST pasteurization, 72 degrees Fahrenheit seconds. Not sterile, commercially safe. Destroys Salmonella, Listeria, tuberculosis bacteria. Shelf life 2 to 3 weeks refrigerated. UHT 135 to 100 degrees. Two, 3 weeks refrigerated. UHT 135 to 100 degrees Celsius under pressure cool label. Safe cans have slightly concave ends. That's the vacuum. Bulging cans are dangerous and must not be consumed. High-acid foods get lacquered interiors to prevent chemical reactions. With the metal shelf life 2 to 5 years, vitamins C and B group take a hit. Chilling 0 to 5 degrees. Slows things down, doesn't kill anything. Freezing -18 to -25. Quick freeze equals small crystals equals minimal damage. Slow freeze equals large crystals equals ruined texture. Blanch vegetables before freezing. Always defrost in the fridge or microwave. Not on the bench. Not ever drying goal. Reduce awe to 5 to 25%. Best, freeze drying via sublimation. Ice straight to vapor under vacuum. No heat. Best quality. Others, spray drying for powders like instant coffee and milk. Tunnel, drum, sun, cabinet, kiln, air drying. They all work. Freeze drying just works best. Fermentation, anaerobic conversion of carbohydrates to acid, alcohol, or CO2. 6 steps. Prepare, add microorganisms. Break down sugars, produce byproducts. Food changes, fermentation stops. 3 principles: exclude air, add chemicals. Lactic acid or alcohol lowers pH and control temperature. Yogurt and cheese from bacteria and mold. Bread from yeast. Kombucha, kimchi, sauerkraut from bacteria. Alcohol from yeast. Soy sauce from mold. Blanching. Boil 30 seconds to 5 minutes. Shock immediately in ice water. Done. Destroys surface bacteria and browning enzymes. Makes greens greener, always precedes freezing. Water activity. Measures free water available for microbial activity. Meat, 0.98. high risk. Chocolate, 0.60, no risk. Goal of drying, get it to 5 to 6%. Packaging, 5 functions. Container, holds the food. Protect from physical damage, environmental elements, and tampering. Preserve, extends shelf life. Excludes contaminants. Convenience, microwave-ready pouches, resealable jars, built-in handles. Inform and promote, mandatory labeling, brand identity, advertising, tamper-evident devices, shrink seals, pop-top lids, foil seals under lids like in Milo and Nutella, plastic ring collars on peanut butter and Vegemite, tear strips, cellophane wrapping. 3 levels of combination packaging. Primary, direct food contact, the wrapper on the muesli bar. Secondary, groups products together, the box holding 6 bars. Tertiary, bulk distribution packaging, large cardboard boxes. Supermarkets want shelf-ready tertiary packaging, perforated, correct dimensions, goes straight on the shelf. Efficiency, 4 materials. Glass, inert, non-porous, odorless, 100% recyclable in 30 days. Transparent or colored, heavy and breakable. Jams, sauces, pickles, plastics, PET for cling wrap, HDPE for milk bottles, LDPE for shrink films, PP for microwave containers and yogurt tubs.
Dual ovenable handles, both microwave and conventional oven, expensive but convenient. Paper and cardboard, carton board, corrugated, molded pulp for egg cartons, laminates for long-life milk. Metals, steel cans need lacquering for high-acid foods, aluminium for drinks and foil, metallized plastic for chip bags. Advantages, cheap, stackable, recyclable. Disadvantages, heavy, and a dented or bulging can is a safety hazard. MAP, modified atmosphere packaging, replaces air with O2, N2, and CO2 mix. 4 methods. Barrier specific. Controls gas rates, anti-fog film, used for fresh produce and salads. Vacuum. Removes all air, cheese, meats, coffee. Doesn't stop anaerobes. Still need refrigeration for meat. Gas. Nitrogen in chip bags inflates packaging and prevents rancidity. Active. Oxygen scavengers delay browning and rancidity. Ethylene scavengers delay fruit ripening. Critical for export. CO2 scavengers. Absorb gas buildup in coffee. Absorbent pads manage meat moisture. Sous vide, cook, vacuum seal in polyester film, blast chill to 3 degrees Celsius, shelf stable for up to 6 weeks, reheat in boiling water or steam. Used in hospitals and nursing homes. Retains color, texture, flavor. The film handles both freezing and high temperature reheating. Practical, aperture approved packaging innovations. Casein-based edible films from milk protein. 500 times better than plastic at blocking oxygen. Biodegradable, sprayable directly onto food. Seaweed packaging from knot blood dissolves in warm water. Zero trace. Smart packaging uses sensors and RFID to monitor temperature, freshness, and ethanol levels through the entire distribution chain. MFC, microfibrillated cellulose from plant waste, stronger than carbon fiber by weight, creates oxygen and moisture barriers. QR codes link consumers to apps, competitions, and social media, all without using label space. Sustainable examples. Plantic Technologies makes cornstarch bioplastic used by Hagues and Cadbury. Brown's Dairy uses ocean-bound plastic tubs. Coca-Cola made the world's first 100% plant-based PET bottle. Mars Wrigley switched to paper. Good drivers for new packaging. Affluence driving convenience demand. Urbanization. Aging population needing easy open systems. Environmental pressure to reduce waste. Consumer safety demands. New technology and stricter legislation. Mandatory label requirements. Food name, batch number, supplier address, allergen declarations, peanuts, tree nuts, crustacea, fish, milk, eggs, sesame, soybeans, wheat, sulfites above 10 milligrams per kilogram, gluten, ingredient list in descending weight order, use by or best before date, nutrition information panel per serve and per 100 grams, characterizing ingredient percentages, storage directions, country of origin, and weight labels. Must not include false or misleading information, disease cure claims, or unjustified vitamin fortification claims. Storage and distribution, cold storage, 0 to 5 degrees. Freezer, -18 to -30. Dry storage, ventilated, max 24 degrees. Controlled humidity, no direct sunlight. Not complicated, just in time. Products move fast, minimal warehouse time, lower costs, less waste, distribution path for canned food, raw materials, factory, warehouse, distribution center, supermarket, by road, rail, air, or sea distribution risks, refrigerated food sitting on warm loading docks,
trucks not cleaned after animal products, temperature breaches during transport, broken glass contaminating other products. All of these are preventable. All of them still happen. That's HSC Food Technology Term 1. Raw materials, additives, equipment, quality systems, legislation, preservation, packaging, storage, all of it. Now, Aperture Science does not offer study guarantees. What we do offer is information, aggressively, efficiently, and without apology. Go study. And if the exam asks about water activity, you better know it's awe, and meat sits at 0.98. Cave Johnson, we're done here.